Alright, let's look at the homework 1.6, problem number 4. Alright, so we have this rational function and we want to find the intervals on which this function is continuous. Alright, so let's do that. Alright, first thing is I'm going to actually factor out the denominator. So you're going to get x minus 3 and x plus 8. And x minus 3. Right, so as you can see that as long as x is not equal to 3, then we can just cancel the common factor on top and bottom. Then we can see that this is just going to be equal to 1 over x plus 8. Right. So the interval is going to be, so x cannot be 3, and also x cannot be equal to negative 8. So let's type it in. Alright, so it's going to from negative infinity to negative 8, and skip negative 8, and then go to 3, and skip 3, then go to infinity, right? And of course discontinuity is going to be at negative 8 and 3. Alright, then let's see, so we want to describe this discontinuity here. So discontinuity when x equals c, so it's c is negative 8 or 3. F of c is not defined, so that's the case, because when x equals negative 8 and 3, denominator is 0, so function is not defined. Alright, so there are two different behaviors. If you look at the limit, let's see, limit of this function as x approaches, say, 3. Alright, so this guy actually exists. So you have 1 over, x is approaching 3, so 3 plus 8, so 1 over 11, right? But if limit as x approaches negative 8, right, that's different, because if it goes to negative 8, it's going to be, so we have to do positive and negative. So for example, let's say we're going to do the, for example, right-hand limit. Then you have a 1 over negative 8 plus 8 would be 0, but it's approaching from the positive side. So this would go to positive infinity. Right, and if you do a negative from the negative direction, so you have x approaches 8 from the left, and you can see that this is going to be 1 over 0, but from the negative side, so this is going to go to negative infinity. Right, either way, the limit does not exist. So here, so limit does not exist. That's one of the reasons why it said there's a discontinuity there. And the limit exists, but they're not equal to each other. So this is also the reason. Alright, so let's check the answer. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.